Let us continue with cryptography. In this video, we are going to learn advanced encryption algorithms like Data Encryption Standard (DES) and Advanced Encryption Standard (AES). The Data Encryption Standard (DES) is an outdated symmetric key method of data encryption. DES is a secret key encryption scheme adopted as a standard in USA in 1977. It uses a 56-bit key, which is today considered by many to be insufficient as it can be cracked by brute force. A variant called triple DES or TDES uses a longer key and is more secure, but has never become popular. The Advanced Encryption Standard, that is AES, is expected to support DES and TDES as a standard encryption algorithm. The Data Encryption Standard, that is the DES, was jointly developed in 1974 by IBM and the US government to set a standard that everyone could use to securely communicate with each other. It operates on blocks of 64 bits using a secret key that is 56 bits long. The original proposal used a secret key that was 64 bits long. It is widely believed that the removal of these 8 bits from the key was done to make it possible for US government agencies to secretly crack messages. DES started out as the Lucifer algorithm developed by IBM. The US National Security Agency (NSA) made several modifications, after which it was adopted as a Federal Information Processing Standard (FIPS) standard, that is 46.3, and ANSI standard X3.92. Have a look at a diagram on your screen. We will discuss steps performed in DES algorithm. The plain text is divided into 64-bit blocks. Initial permutation is performed on 64-bit plain text block. After initial permutation, block is divided into two halves of 32-bit each, left plain text L and right plain text R. L and R go through 16 rounds, each of which is fed with the 48B subkey. The round key generator is an algorithm which is fed with an input of 56-bit key and it gives the output of 48-bit round key. In case of DES, the round key algorithm is invoked 16 times. After 16 rounds, L and R are combined and then the final permutation is performed on a combined block of 64 bits. The result of this process produces a 64-bit ciphertext block. After all the blocks are processed, we get a combined full-length ciphertext. DES was quite influential at that time and is simple enough to understand for building blocks using modern ciphers, but by now it is considered obsolete and insecure. Some of the disadvantages of DES are weak keys. The key that is selected on the rounds are problem. During splitting of keys into two halves and swapping them might throw same result if they have continuous ones and zeros. This ends up in using the same key throughout the 16 cycles. There can be same output from different inputs on permutation. These are called semi-weak keys. If the message is encrypted with a particular key and is taken, one's complement of that encryption will be the same as the encryption of the complement of the message and complement of the key. Let us start with Advanced Encryption Standard (AES). AES is a symmetric key encryption standard for secret key encryption. AES was created by two Belgian cryptographers, Vincent Rijman and John Damon, as a replacement of the old DES. The standard comprises with three block ciphers: AES 128, AES 192 and AES 256. Each of these ciphers has a 128-bit block size with key size of 128, 192 and 256 bits respectively. The algorithm is named Rijndael and has several simple steps of known cryptographic mechanisms that are put in chain together, so it is effectively hard to crack the algorithm. The heart of algorithm is around the S-box mechanism, substitution, then a second step about transposition, a matrix operation influenced by the classical Hill cipher, and this is all going over and over and made it quite complex to break. AES has been adopted by the US government and is now used worldwide. It supersedes the Data Encryption Standard, that is the DES, which was published in 1977. The algorithm described by AES is a symmetric key algorithm, meaning the same key is used for both encrypting and decrypting the data. Now, I will tell you why AES replaced DES with new and updated features. AES had block encryption implementation, 128 group encryption with 128, 192 and 256-bit key lengths. Symmetric algorithm requiring only one encryption and decryption key. Data security for over 20 to 30 years. Worldwide access, no royalties and overall easy implementation. In the next lecture, we will see asymmetric encryption with a real life example.